Language and Bilingualism in the Brain by Madison Force and Nico Natachowski. Humans perceive language in two different ways, the spoken word and the written word. Humans take auditory and visual stimuli and they perceive this as language in the brain. Once language is understood, humans are able to use language to speak and to write what they are thinking. There are two main brain systems involved in language, Wernicke's area and Broca's area. In 90% of people, these areas are lateralized on the left hemisphere of the brain. Wernicke's area is responsible for the comprehension of speech, and Broca's area is responsible for the production of speech. These two language areas are connected by the arcuate fasciculus. This is a track of white matter that carries information in both directions in between the two areas. When perceiving spoken language, the sounds come in through the auditory pathways to the primary auditory cortex in the temporal lobe. The primary auditory cortex is located on the superior temporal gyrus. The frequencies are then transferred to Wernicke's area where they are made sense of, and across the arcuate fasciculus to Broca's area where they are repeated in your head when you think about the words. Perceiving written language, the pathways have an extra step. The written words are perceived when the primary visual cortex in the occipital lobe receives visual stimuli from the eyes. This cortex is called V1. The stimulation is then transferred down the ventral pathway through cortical areas V2 and V4. This is called the what pathway that recognizes the letters and forms them into words. When reading words, you say them to yourself in your head. This is when they're transferred from the what pathway to the auditory cortex. The words then go through the same steps that spoken words do. For producing language, information is sent from Broca's area to the primary motor cortex that is responsible for moving the mouth to speak or moving the hand to write. People often say that language is the key to human intelligence. It is these brain regions and pathways that distinguish human intelligence from other animals. Recently, studies have shown that people who speak multiple languages have better attention and cognition. These brain regions and pathways that give humans the gift of communication are all doubled in the bilingual brain. When a bilingual brain receives any language, the brain networks for both languages are active. This strengthens the pathways in the brain, making the language network stronger. Thinking, understanding, speaking, or writing in just one language requires deliberately paying attention to one and deliberately ignoring the other language. The brain's decision-making executive controls are constantly deciding which networks to activate and which signals to ignore in order to understand or produce just one language. Over time, these executive controls are strengthened and focusing on just one language becomes easier. These executive controls do not only coordinate language in the brain. The executive functions are used for directing focus, paying attention, prioritizing, planning, controlling, judging, and analyzing everything that comes into the brain. A bilingual brain with stronger executive functions is better at focusing, paying attention, sorting, and organizing thoughts and actions, as well as multitasking. Bilingualism benefits the brain throughout an entire lifespan. Over the years, our brains age, which leads to loss of cognitive function and memory. Researchers suggest a way to combat this cognitive loss is by keeping the brain active. You could do this with crossword puzzles or playing an instrument. But recent bilingual research is showing that speaking multiple languages may be the best way to combat the damaging cognitive effects of aging because you use language in every minute of every day. If language is the key to human intelligence, then bilingualism must be the key to increasing human intelligence.
Created using Powtoon.